Hi, this is Tony from oddwires.co.uk. Just want to spend a few minutes to show you my latest little gizmo, which is running away here. This is based around these things, which are just radio controlled main sockets, and I've also got a few of these little night lights, which are just used to show if a main socket is on or off. So you just drop that in there and pop that in with the rest of it. So as you can see, we've got the lights being controlled by the Raspberry Pi, and they're just running through a sequence there. I'm just going to stop the sequence to explain a bit more about what's going on. When you buy the sockets, they always come with one of these, which is a little handheld remote control unit. It allows you to turn the lights, the sockets, on or off. Now you can probably spot the obvious limitation there. This has only got 5 buttons. I've got 6 lights. So I was looking for a way to address more than 5 lights at a time, and I've come up with this solution based around the inevitable Raspberry Pi and a little PIC processor which is driving this radio transmitter. So let's just have a quick zoom in on the technology. So this is an I2C interface, and also a couple of pins used for power. So the red wire is the 3.3 volt power supply, black is ground, green and white are the data and clock of the I2C bus. So all of that is passed into this little thing here, which is a PIC chip. It's actually the PIC 12LF1552. It runs at 3.3 volts, so it's quite happy pulling its power from the Raspberry Pi. It's got its own I2C interface, and we're actually only using this one output line here. So what goes on inside there is there's a PIC program which emulates the handset protocols. So it receives commands from the I2C bus, translates them into the same protocol used by the handsets, and outputs it all on that single pin. So then the data is passed down here to this thing, which is a surface acoustic wave radio transmitter. Little aerial on the back, and that just transmits the signal, and that in turn needs the 9 volt battery to power it. So there's not really a great deal to the circuit, it's really rather simple. So what does the software look like to control this? Well, we're working over the I2C bus, so a good place to start is the I2C detect utility. Interactive mode bus 1. Now you can see on the first line there that a device has responded on address 08. Now that's the PIC processor. So to talk to the PIC processor over the I2C bus, we're going to need address 8. So the actual command looks like I2C set, interactive mode, bus 1, PIC processor on 8. So that's talking to the PIC. Now it needs 2 more bytes of information. Now the first byte is a number. Now imagine you've got a whole box of these. In fact there's 32 of them, and each one is different. So each one has got a number in the range of 1 to 32. So I just happen to know that this device here, this handset, is operating on address 7. So we'll just put in 7, and then the next digit, next byte, is broken down into 2 digits. Now the first represents a channel number. That's a number in the range 1 to 5, so we'll have channel 1. And the last digit is the function. Now 0 represents off, any other number represents on, so we'll have 1 for on. So that represents channel 1 on. And there it goes. Similarly, 0 for off, channel 1 off. Or channel 2 on, channel 2 off. So how does that help us address that 6th light? Well, I've set that 6th socket up to respond to a different handset number. So this is responding to handset 0, channel 1 on, and there you go. Similarly off. So we've got the equivalent of 32 handsets, each with 5 channels. That's 160 individually addressable power sockets there. So that's quite a lot of channels for normal domestic use. But you can go a little bit further in that each one of those sockets will actually respond to 4 different control codes. So I've actually programmed all these sockets to respond to handset 8, channel 1. On and off. So then moving on from there, it's very easy to just set up a shell script, which is a continual loop, and it just keeps sending out those commands in a sequence. So there it goes. So this has been Tony from oddwires.co.uk. Thanks for watching.